Learning about soil. Soil types. Weathering of rocks produces small particles of various materials. These include sand and clay. The relative amount of sand and clay depends upon the rock from which the particles are formed, that is, the parent rock. The mixture of rock particles and humus is called the soil. Living organisms such as bacteria, plant roots, and earthworm are also important parts of any soil. The soil is classified on the basis of the proportion of particles of various sizes. If soil contains greater proportion of big particles, it is called sandy soil. The sizes of the particles in a soil have a very important influence on its properties. Sand particles are quite large. They cannot fit closely together. So, there are large spaces between them. These spaces are filled with air. We say that the sand is well aerated. Water can drain quickly through the spaces between the sand particles. So, sandy soils tend to be light, well aerated, and rather dry. If the proportion of the fine particles is relatively higher, then it is called clayey soil. Clay particles, being much smaller, pack tightly together, leaving little space for air. Unlike sandy soil, water can be held in the tiny gaps between the particles of clay. So, clay soils have little air, but they are heavy as they hold more water than the sandy soils. If the amount of large and fine particles is about the same, then the soil is called loamy. Thus, the soil can be classified as sandy, clay, and loamy. The best topsoil for growing plants is loamy. Loamy soil is a mixture of sand, clay, and another type of soil particle known as silt. Silt occurs as a deposit in riverbeds. The size of the silt particle is between those of sand and clay. The loamy soil also has humus in it. It has the right water holding capacity for the growth of plants. Activity. Take a fistful of black soil. Remove any pebbles, rocks, or grass blades from it. Now add water drop by drop and knead the soil. Add just enough water so that a ball can be made from it. But at the same time, it should not be sticky. Try to make a ball from this soil. On a flat surface, roll this ball into a cylinder. Try to make a ring from this cylinder. Black soil should be used for making pots, toys, and statues. Properties of soil. The characteristics of the soil. Mark two different squares of 50 cm each. One on the floor of the house and the other on the kacha, unpaved road. Fill 2 bottles of the same size with water. Empty the water from the bottles, one each at the same time in the 2 squares. Observe that the water on the floor flowed down and was not absorbed. On the Kacha road, on the other hand, the water was absorbed. Now let us perform an activity to understand this. Activity. Let us see why there was a difference in the absorption of water in two squares. In this activity, you will be finding out how fast the water passes down the soil. At the place where you collect the soil, place the pipe about 2 centimeters deep in the ground. Pour 200 ml water in the pipe slowly. For measuring 200 ml water, you can use an empty 200 ml bottle. Note the time when you start pouring the water. When all the water has percolated, leaving the pipe empty, note the time again. Be careful not to let the water spill over or run down on the outside of the pipe while pouring. Calculate the rate of percolation by using the following formula. Percolation rate ml per minute is equal to amount of water ml upon percolation time in minutes. For example, suppose that for a certain sample, it took 20 minutes for 200 ml to percolate. So,
rate of percolation is equal to 200 ml upon 20 minutes is equal to 10 ml per minute. The rate of percolation in our soil is 10 ml per minute.
Moisture in soil. Activity. Take a boiling tube. Put 2 spoonfuls of soil sample in it. Heat it on a flame and observe it. On heating, water in the soil evaporates, moves up and condenses on the cooler inner walls of the upper part of the boiling tube. After heating the soil, take it out of the tube. Compare it with the soil which has not been heated. Have you ever passed through a farmland during a hot summer day? Perhaps you notice that the air above the land is shimmering. Why is it so? On a hot summer day, the vapors coming out of the soil reflect the sunlight and the air above the soil seems to shimmer. Do all the soils absorb water to the same extent? Let us find out. Activity. Take a plastic funnel. Take a filter paper or a piece of newspaper sheet. Fold it in the shape of a funnel. Weigh 50 grams of dry, powdered soil and pour it into the funnel. Measure a certain amount of water in a measuring cylinder and pour it drop by drop on the soil. You can use a dropper for this purpose. Do not let all the water fall at one spot. Pour water all over the soil. Keep pouring water till it starts dripping. Subtract the amount of water left in the measuring cylinder from the amount you started with. This is the amount of water retained by the soil. Record your results in your notebook in the following manner. Weight of the soil is equal to 50 grams. Initial volume of water in the measuring cylinder is equal to U is equal to
200 ml.
Final volume of water in the measuring cylinder is equal to V is equal to
50 ml.
Volume of water absorbed by the soil is equal to, in bracket, U minus V
ml,
that is 200 minus 50
ml.
Weight of water absorbed by the soil is equal to U minus V gram, that is 150 gram,
1 ml of water has weight
equal to 1 gram. Percentage of water absorbed is equal to U minus V upon 50 multiplied by 100. Percentage of water absorbed is equal to 200 minus 50 upon 50 in 200. Therefore, percentage of water absorbed is equal to
300 ml.
Summary. Percolation rate of water is different in different types of soils. It is highest in sandy soil and least in clay soil. Different types of soils are used to cultivate different types of crops. Clay and loam are suitable for growing wheat, gram, and paddy. Cotton is grown in sandy loam soil. That is all in this subtopic, students. Let us learn more about soil and crop in our next topic.